Good morning, students, and welcome to our lesson on slope-intercept form. So today we are really into the heart and the central ideas behind algebra. So for our do now, we have a prompt about types of anger. It doesn't sound fun, but it is interesting. I think you'll get something out of it if you commit to trying to do so. Our objective will be to learn the slope-intercept form of an equation. So our essential question is, what is the slope-intercept form of an equation? And how can I derive or find the slope-intercept form of an equation from a graph? So we'll be looking at some graphs today. Our assignment will be to watch today's video and work the 2 pages on slope-intercept form. And for our exit ticket, I'd like you to complete the sentence, the slope-intercept form of an equation is blank, where M is the blank and B is the blank. So for homework, you don't have a homework specific to this lesson because this is part 1 of another lesson. You'll have a homework tomorrow for that, or Thursday. But here's what I want you to do. I want you to develop a plan to complete and turn in all of your Unit 4 assignments. Also, if you have a smartphone, I'd like you to install Teams and then sign into your account and then know how or learn how to upload photos. I've been told by students and shown by students how absolutely easy and seamless it is for the way I've run this math class. So just a way to save you time. So if you have a smartphone and you're so inclined, I'd like you to try that. Remember to get full participation credit. We want your camera on during class. We want you to respond when your name is called, which could be the beginning, middle, or end of the period. We want you to submit your completed assignment each day in Teams. And if you have questions, please ask them. I'd like you to look for and complete the Wednesday assignment. So in our theme this week of obscure holidays, today is Pretend to be a Time Traveler Day. These holidays are made up by industries or groups of people, and they get them approved to be a national holiday. They're obscure. Very few people know about them. I just think they're kind of fun. So, in honor of Pretend to be a Time Traveler Day, let's travel ahead to your next report card and make some positive predictions. Are you headed in the right direction? Well, that calls for a linear graph. So I thought that picture was kind of fun. So here is our do now. Let's explore the subtle difference between emotions. Anger can be selfish, like a temper tantrum, or outwardly triggered, like justifiable anger. How are these different? When I think of selfish anger, I have a 2-year-old grandson, and oh goodness, when he wants something, he just wants it. That's it. It's always something he wants, and he doesn't really have a lot of words yet. He's just starting to make sentences, and sometimes they're not easy to understand. And if he wanted ice cream, let's say, he would just, I want ice cream, and well, no, you had some ice cream. It's enough ice cream for now. And of course, he would just kind of, I want ice cream, and have a little temper tantrum. And that's how 2-year-olds handle things because they don't have the skills to handle them in any other way. But then, I think about this summer when we had so many protests, the Black Lives Matter protests and the racial justice protests, and those were in response to bad things that happened. And those are outwardly triggered by an event outside yourself. And those were a wonderful example of justifiable anger. People were angry at some injustice, so they chose to have take some kind of action in response to that. So why is this important? Well, recognizing different types of anger can sometimes help you identify an anger you might feel in yourself. And if you recognize how your response is, if you're just complaining about your grade, maybe that's a little bit like a temper tantrum because you're not thinking about the effort you need to put in to do well in a class. But if you're complaining about maybe the food in the cafeteria, well, maybe that's a justifiable anger, and maybe there's some improvement that could be made. So seeing the difference in your anger can sometimes help you. Of course, maybe if you're complaining about the food in the cafeteria, you just need to expand your palate a little bit as well. So there's our exit ticket. We'll get back to that. So here we are, slope-intercept form. So linear equations, equations that result in a line, we see that word there, are frequently written in slope-intercept form. And slope-intercept form is y equals mx plus b. So I'm actually going to get another document because I want to talk about that a little bit. So slope-intercept form of an equation. So we have this y equals mx plus b. Okay, and what we're really saying here is the value of y. The value of the function at y is equal to the slope of the equation. We talked about yesterday, m is slope. Okay, multiplied by the value of x. Okay, multiplied by a value of x. Remember, two things next to each other, that's multiplication. Okay, plus the y-intercept. Now, when we say plus, sometimes it's not plus, sometimes it's minus. Okay, plus or minus the y-intercept. And I really want you to commit this to memory. We're getting into the portion of algebra where you really need to start remembering things. You know, y equals mx plus b. And remember, it could be plus or minus b, depending on the linear equation, where m is the slope, b is the y-intercept, x is the input, and y is the output. Let's get back to our paper. So linear equations are frequently written in slope-intercept form, where m is the slope and b is the y-intercept. So for the next few problems, our instructions are, given the slope, okay, so we already know the angle of this line, and the y-intercept of the line, write an equation in slope-intercept form. So we're writing an equation, we're going to have an equal sign, and we need to use this y equals mx plus b form to do so. So number one, the slope is 2, the y-intercept is -1. So y equals 2x, because this is our m value. And we say plus b, but here we have a -1. So it would be -1. That's it. So number 2, our slope is -3/5. Our y-intercept is 4. So y equals -3/5 x plus 4. You want to try the rest of them, 3, 4, 5, and 6 yourself, and then come back to the video? I think that's a good idea. So pause the video for a minute and then come back. Okay, let's see how you did. So the slope is -3, the y-intercept is 2. So the value of the function at y is equal to -3 times the value of x plus 2. Number 4, we have a slope of -1 and a y-intercept of 7. So the value of this function at y is equal to -1x. And then what happens? What happens when we have -1x? We have an invisible 1. Hope you got that on your own. Good job. So that would be -x plus 7. Number 5, we have a slope of 1/4 and a y-intercept of 0. Here's what happens here. The value of the function at y equals 1/4 x. Now you might be tempted to write plus 0, but it's not necessary to do that. The slope is x. And you will see as we move on that this function will go through the origin of the coordinate plane. And number 6, our slope is -5/2. Our y-intercept is -3. So the value of the function at y equals -5/2x minus 3. How did you do with that? So now we're given a graph. So we're going to put together a little bit of what we did yesterday with some of this new material that we just learned. So we're asked to identify the slope and the y-intercept of the line on the graph. Then we're going to write the equation of the line in slope-intercept form. So we have 2 points here. Let's look at the slope. So the slope has a rise of 1, 2, 3, and a run of 1. Okay, 1, 2, 3, and a run of 1. So we can simplify that. Remember, we don't have mixed numbers. We leave improper fractions as they are, but we do simplify them as much as possible. And where we have 1 as a denominator, we recognize that that's a whole number and the slope is 3. Now, let's look at the y-intercept. I'm going to erase this so we can see it a little bit more clearly. The y-intercept is, let's write this down, is where the graph crosses the y-axis. Okay, now where does that happen here? Well, here's our y-axis. It crosses the y-axis at -1, 2, 3, 4, at -4. So our b value is -4. So our equation, we put this together like we did with the problems above, is y equals 3x minus 4. Now here we've got, in number 7, we have a positive slope. Okay, we're climbing up a hill, hiking up the mountain. In number 8, we have a negative slope. So when we see this negative slope, remember, I always say, imagine coming down a sled and crashing into the tree. So when we have a negative slope, our m value will be negative. So m will be negative. So what is the m value? Let's take a look at the graph. Here's a point and here's a point. So we have a rise of -1, 2, 3, 4, 5, 6, a rise of -6 over a run of +1, 2, 3, 1, 2, 3, 4. So -6/4. Remember, only the numerator or the denominator can be negative when we have negative slope. If both were negative, then the slope would be positive because a negative divided by a negative is a positive. Now we can simplify this to -3/2 by dividing both of those by 2. Now our y-intercept, where is this graph crossing the y-axis? I'm going to clean it up a little so you can see it more easily. If we look at that graph, it's crossing the y-axis at 0, 1, 2, 3, 4, 5, 6, 7, at 7. So the equation, y equals negative, we use the simplified version, -3/2 x plus 7. So one thing you might notice already about the y-intercept is that when the y-intercept is below the origin, here's the origin, 0, 0. When the y-intercept is below the origin, the b value is negative. When the y-intercept is above the origin, the b value is positive. So let's look at number 9. Maybe you should try some of these yourself and then come back. We've got 8 more to do. Maybe you want to do a couple more with me. But I always suggest that you try at least some of them on your own and see if you're getting it. So here for number 9, 10, 11, 12, 13, and 14, 15, and 16, they didn't give us a separate line to write the slope and the y-intercept, but we can still do that. So the slope is 2 over 1, 2, 3, 4, 5. 2 over 5. The y-intercept is -3. So y equals 2/5 x minus 3. So on numbers 10, the slope, now look at this. We have 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. 5 over 5 equals 1. So our slope is 1, and our y-intercept is -1, -2, -3, -4, -5, -6. So remember, when we have a 1 as a slope, that becomes an invisible 1. So y equals x minus 6. Number 11. So let's look at the slope. Here are our 2 points. Now, if they don't give you 2 points, you can just identify any 2 points that lie exactly on the intersection of the grid. So you wouldn't want to find a point there. That wouldn't help you very much. But what you would want to do is find a point here and maybe another point here. You always want to look where the point lies on the intersection of the grid. So here we have a negative slope. It's going downhill. So I'm going to go down, and we go down 1, 2. So m equals -2 over 1, 2, 3, 4, 5, 6, 7, 8 over 8, and we can reduce that to -1/4. So our slope is -1/4, and our y-intercept, let's clean up the graph a little bit so we can see it. So this is 0, 1, 2, 3, 4, 5. So our b value, our y-intercept, is 5. So our equation y equals -1/4 x plus 5. Now this graph, number 12, goes right through the origin. Let's figure the slope first. The slope is 1, 2, 3, 4 over 1, 2, 3. So the slope is 4/3. Now the y-intercept is at 0, 0. This is 0.00. And the y value here is 0. So b equals 0. So our slope-intercept form of this equation is y equals 4/3 x. That's it. We don't have to put plus or minus 0. We just stop right there. That's our final answer. So number 13, we have a negative slope. So let's count. We're going to, our rise is -1, 2, 3, 4, 5, 6, 7, 8. So we have -8 in the numerator and a +1, 2, 3, 4 in the denominator. And that simplifies to -2. And the graph crosses the y-axis at -1, 2, 3, -3. So our equation, y equals -2x minus 3. And number 14, again, we see that this is a negative slope, and our rise, which is -1, 2, 3, 4, 5. So we have negative 5 in the numerator. In the denominator, we have 1, 2, 3, 4, 5, 6. So negative 5 over 6 is our slope. And this graph crosses the y-axis at positive 1. Now, this cannot be an invisible 1. We have to show that this graph rises up above the origin. So we have to put, and also remember, this is a constant. This is not a coefficient in front of a variable. So that cannot be invisible. So we're going to have y equals negative 5 over 6x. And we have to show that plus 1 because we've risen up 1 unit from the origin. Were you able to catch that on your own? Good eye if you did. Okay, last two problems. So let's look at our slope. It's positive. We have a gentle slope, but it is in the positive direction. We have a rise of 1, 2 over a run of 1, 2, 3, 4, 5, 6, and we can reduce that to 1/3. And the y-intercept, the place where this graph crosses the y-axis, is negative 2. So our equation for this graph is y equals 1/3 x minus 2. And our final graph of the day has a negative slope, a very steep negative slope. So let's figure out what that is. We'll start with this point right here. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a negative 10 over 1, 2. And that simplifies to negative 5. So our slope is negative 5, and our y-intercept is, this is our origin, our 0. 1, 2, 3, 4, 5, 6, 7, 8. Our y-intercept is 8. So we have an equation of y equals negative 5x plus 8. So that's slope-intercept form. Students, slope-intercept form is one of your best friends in algebra. You can convert many equations to slope-intercept form, and that enables you to easily graph them because you can tell what the slope should be and what the y-intercept of the equation should be. So let's go back to our exit ticket. So the slope-intercept form of an equation is y equals mx plus b, where m is the slope and b is the y-intercept. So that's it for today. I gave you kind of a special homework. I want to make sure that you really are good at uploading your photos of your work onto Teams. And I want you to make sure that you have a plan to turn in all of our Unit 4 assignments. Believe me, a lot of algebra isn't good test taking. It's good effort. And if you do that, you can be very, very, very successful. And I want you to time travel your way to your next report card and see those amazing grades and reflect and bask in the hard work that you did because you've got the ability. You can do this. This is a crazy school year, but that does not mean that you don't deserve to honor yourself by putting in your best effort every day. So keep practicing, and as always, when you do, you'll be great.